Hi students, today we are discussing about fraunhofer diffraction due to double slit. We already discussed about single slit in yesterday's class. Today we are discussed about fraunhofer diffraction due to double slits. Okay, let us see fraunhofer diffraction. For this diffraction also we are using a slit, but there is a double slit. Okay, according to the name we are using a double slit, that means two slits. Let us see. Let S1 and S2 be double slits of equal widths E and separated by a distance D. So whenever we are using a single slit, its width is also E. Here the slit width also E, but we are using two slits and those two slits are separated by a distance D. Now the distance between the middle points of the two slits is, read again, the distance between the middle points of the two slits, that is E plus D. Okay, now a monochromatic light of wavelength lambda is incident on the two slits. We are taking again a monochromatic light of wavelength lambda that is incident on the two slits. Now the light diffracted from these slits is focused by a lens of the screen. So here also we are again using a convex lens. Now the diffraction at two slits is the combination of diffraction as well as interference. We know the interference condition and diffraction condition. In this double slit experiment, we are having the both diffraction as well as interference pattern. Now the wavelets traveling in a direction of incident light come to a focus at point P. That means we are having the central maxima and minimas also. Now P0 is a central maxima. Now by the wavelets traveling in a direction making an angle theta comes to focus at P1. So P1 is said to be a minima with making angle of theta, the rays coming from the source, that makes angle theta with the principal maxima. So see here we are using two sources, two slits S1 and S2 which are separated at a distance D and having the slit width E. Now that is said to be E plus D, and it is also the difference between the images P0 and P1 which we are obtained in the screen. The angle changes from the change of angle between the rays is theta. Okay, here also we are using the lens. We already know the resultant amplitude due to single slit is A sin alpha by alpha, where alpha equals to pi e sin theta by lambda. In this double slit condition, from each slit we get a wavelet of amplitude A sin alpha by alpha in a direction theta, because for the single slit we are getting a value of A sin alpha by alpha, but here we are using two slits, so that what will happen, from each slit we will get a wavelet of amplitude A sin alpha by alpha in a direction theta. That means it makes an angle theta. To calculate the path difference between the wavelets, let us draw a normal S1k to the wave S2k. See here, there is a normal k which are drawn from this which makes a triangle like S1 S2k. There is a normal. Let us draw the normal S1k to the wave S2k. Now the path difference becomes S2k. That means we are getting the sin theta. Here the slit width is along with the distance, that means separations, that is E plus D into sin theta. Now the phase difference, that is delta, that is equal to, here is the phase difference of 2 pi by lambda into this. We already know these two conditions in the single slit. Okay, now to find the resultant amplitude at P1, that means at the central maxima, we use vector method. See, there is an example like this. So it is a OGH, that is a triangle, and the hypotenuse OH that has a value of R, and OG, that is a sin alpha by alpha, and GH, that is a sin alpha by alpha. From this, what is this? you just have to go through your mathematics. You will definitely recall this. Okay, now OH square equals to OG square plus GH square plus OG into GH, that is there is a 2 GH into cos delta. Now R square, OH means R square, that equals to OG, A sin alpha by alpha, right? Now A square sin square alpha by alpha whole square plus A square into, again that value is also sin alpha by alpha whole square plus 2 into A sin alpha by alpha into A sin alpha by alpha into cos delta. Now R square equals to A square sin square alpha by alpha whole square. We are making common, that means we are taking the common fraction, that is A square sin square alpha by alpha square, that equals to 1 plus 1 becomes 2 plus 2 cos delta, 2 cos delta. Now we know that 1 plus cos delta equals to 2 cos square delta by 2. We are substituting this instead of 1 plus cos theta. Now here is a small modification, you can just make it in your notebook. And to here, A square sin square alpha by alpha square, A square sin square alpha by alpha square, this is the alpha square, and instead of this 2 cos square delta by 2, there is no need of these 2's. Okay, and here let us see what will happen. A square sin square alpha, here also is a 2, here is a 2. Okay, with this equation we are having a 2, and from here we are making a common number 2. So 2 into 2 becomes 4 A square sin square alpha by alpha square into cos square delta square, that means cos square delta by 2. Delta by 2 means we know that value of delta, that is 2 pi into e plus the path difference is 2 pi by lambda and e plus d sin theta, which is the it's a path difference, that is a phase difference. Delta is a phase difference. Now R square equals to 4A square sin square alpha by alpha whole square cos square delta. We are substituting the delta value simply. Now R square equals to 4A square sin alpha by alpha whole square, that means completely it's a square, and cos square regarding this, that means it is taking this value as beta. Okay, beta equals to pi plus pi into e plus d into sin theta by lambda. And next, from the above expression it is clear that A square into sin alpha by alpha whole square represents the diffraction pattern due to single slit, and cos square beta represents the interference pattern due to a double slit. So here it A square into sin square alpha by alpha whole square, it represents the diffraction pattern according to the single slit. And what we gain here, additionally we got cos square beta, so this introduced the interference pattern. That becomes the double slit experiment exposes both interference and diffraction pattern, as we said in the earlier topic. And now what is diffraction effect? Let us see. So the diffraction term A square into sin alpha by alpha whole square gives the principal maximum at the center of the screen with alternate minima and secondary maxima of decreasing intensity. We already discussed this about central maxima, that means primary maxima, secondary maxima, what is the minima. We already discussed that. Same topic is again we are discussing, that means in every between two minimas there is a secondary maxima. Okay, and see in this diagram we get the principal maxima for theta equals to 0. We get the minimum for sin alpha equals to 0 or alpha equals to plus or minus m pi. Okay, now E sin theta equals to plus or minus m lambda. Pi gets cancelled and here it becomes m lambda, where m is the 1, 2, 3 and so on. M has the values. Now the position of secondary maxima occurs where the position, this is the, for theta equals to 0 we are getting the principal maxima. Then where we are getting the secondary maxima, it will occurs for alpha equals to plus or minus 3 pi by 2. Here is a secondary maxima. Okay, in between two maximas there is a minima, and in between two minimas there is a secondary maxima. Is it? And next, interference effect. What is the interference effect? Let us see. The interference term cos square beta gives the equidistant bright and dark fringes. We already know whenever we are taking a parallel glass plates, we can get the fringes, bright and dark fringes alternatively. In the concept of Newton rings also, we can get the alternate bright and dark rings. Like that, here we are also getting the bright and dark rings due to the interference pattern which are having the value cos square beta. Maximum will occur for cos square beta equals to 1. That means beta value. For beta values, beta equals to plus or minus n pi, where n equals to 0, 1, 2, 3 and so on. Here we know that the beta value is pi into e plus d into sine theta by lambda, that is equal to plus or minus n pi. Now pi gets cancelled and lambda will go to the other side. That means e plus d sine theta equals to plus or minus n lambda. Then where will occur? Minimum will occur. So maximum will occur for cos square beta equals to 1. Where will you get the minimum? Minimum will occur for cos square beta equals to 0. That means beta equals to plus or minus 2n plus 1 into pi by 2. And that is a phase change of pi by 2. Now beta equals to this value, that becomes pi gets cancelled, and this is a lambda by 2, not a pi by 2, it is a lambda by 2. Sorry, it becomes lambda by 2. Okay, and now intensity distribution. See how the intensity will distribute. So at 0 we can get the maximum, at for these values we can get the minima conditions. These two will combine in the next case. See, the resultant intensity due to the double slit will have like this. That means when both effects are combined, then we get the resultant intensity variation. It is clear that the resultant minima are not equal to 0. The minima that is not equal to 0. Still they have some minimum intensity due to interference effect. Okay, when we are talking about the diffraction pattern, that is a there is a maximum intensity, minimum intensity. The minimum intensity, that is not equal to 0, because whenever the interference pattern includes that interferes, okay, we can get the, still they have the some minimum intensity position also have some value due to the interference effect. Okay, it is simply about interference due to double slit. Okay, and next let us see, uh, okay,